Hello, everybody. My name is Jim McLeese, and this is my final project for Geography 481. The area that I am doing my project in, as I mentioned before in the other presentations, is Williamsburg, Virginia. And here's a little picture of the governor's mansion in Williamsburg. And for those of you who don't know where Williamsburg, Virginia is, it's in southeastern Virginia. Here's a little map inside of Virginia, North Carolina, showing the Outer Banks, and Williamsburg's right there by the little airport icon. Nice city between Norfolk and Richmond. My project idea, I started off wanting to look at heat islands, um, but I am going to be comparing and contrasting contour maps, and I'm going to be looking at a data set that I classify by taking all the points back to ground, and then a data set that's already been classified. Look at the difference between the contours, look at the difference between some digital elevation models, and see how they compare and contrast. The data came from VGen, which is the Virginia's LiDAR network. And you just click on the little tiles and you can get them. The data was prepared by Fugro USA Land, and it was prepared for the United States Geological Survey. Some of the metadata I shared last time, but it is aircraft-based data. What I didn't share last time was the aircraft was a Cessna 310. The scanning hertz were at 35. The pulse rate was 4426. This is some of the data that I discovered after the project proposal, and it's kind of cool. I've come up with quite a bit more info. I got some flight records and probably too much data to share here in this presentation. I got from FlightAware, so I found the tail number of the aircraft. November 9 or 7 Hotel Charlie. So I pulled that up, and it's a Cessna 310. It was flown out of Richmond for this mission, KRIC, and I was able to find the pilot's name. That was Jonathan Spencer. So if you look, you can find an awful lot of data if you're willing to dig kind of deep to get it. So the software I'm using is LP360, and I am doing a number of different point cloud tests. As I mentioned the last time, the ones that are here on the screen, initialize, which just sets all the points back to 0. Class 12 non-ground, that's going to move all but the last returns to class 12. And then we filter out some noise with low points single and low points group. And finally, we're going to densify the ground. So for hydro flattening, I had downloaded a shapefile that was provided by Fugro, and it extended beyond my limits. So when I did the contours, it just didn't look right. So I finally decided to just go ahead and digitize my own shapefiles. So here's a little picture of me doing that. The hydro flattening steps obviously is to create digitize the shapefile. You do have to convert that into 3D. There's a PCT to do that, and then you can enforce that 3D polygon uh, um, break line in the layer. Alrighty, so here is one that I did that was not break line enforced. So you can see the difference. The tins go all the way across the water. It's not a flat surface, not very pretty, and of course USGS does not want digital elevation models or contours made out of this. So here we have one that already is hydroflattened. So this is a little island on a sticking out on a peninsula. It is kind of attached to land there, so where you see that's completely flat, that is exactly where I wanted it. So around the little island is attached back to land. So that's really a little peninsula there, but it's a good graphic of hydro flattening exactly where I wanted it. And here's some hydro flattening of a lake that's a little bit farther to the north. And this was kind of a bear digitizing. Took me a little while. But I got her done. All right, so we also have to classify vegetation. This is another point cloud task. And you put your values in there, for how high you want your low to be, your mid, and your high. Then you have your high noise. So I did have to classify the vegetation. The original data did not have vegetation classed in it, so it's interesting to see the results. All right, I also had to classify the bridge decks by polygon. So here's a little example of me classifying a bridge deck. There are only two to classify in there. And that's just where they went across Highway 199. So when I ran the classified buildings PCT, did want to check. So there's a lot of houses in my area, so I went in there to make sure that there were no ground points on top of the roofs, because that would mess up my demo, my contours. Also, I had to use a point cloud task to reclassify the buildings when there were still some ground points on top of the roofs. So this is a little example of me reclassifying the ground points that are still up on top of the roofs, and there were quite a few of those. That was rather arduous. Um, Here is the contours made from my completely reset LiDAR points. So this is hydro flattened. Bridge decks are done. We have taken the ground points off of all the buildings and created a hydro enforced 10 of elevation data, and I put some hill shading on this as well. Alrighty, so here are the contours made from the control. Looks a little bit different, but really not all that much. Largely the same contours. I did notice, some areas where there were just very minor differences. Overall, not a whole heck of a lot. Um, but there are some areas where I've got a little bit more granularity in what I did versus the data that came from Fugro. And finally, this is the most interesting. This is the model key. So this is using the data from Fugro, and I use the model key ground points to create contours here. And I don't see much difference between the contours generated from my control data and contours generated from model key. So model key seems to be a viable option if one so chooses to do that. All right, I wanted to zoom in just a little bit to show that some of these contours are really not that much different. Take a little look here. This is the control, and this is again the already classified data from Fugro, and then I did the hydro enforced elevation model, and we'll take a look at the model key. So here are the model keys. And you notice they're very similar. They're not much different at all. So I was kind of surprised to see that. And yet again, with my experience in land surveying, maybe not so surprised. And I'll get into that in a minute. So my point count comparison, very similar. So after I classified all the points, I came up with a point count for my ground points of 14,645,135. And the data that was classified by Fugro, 14,102 and 63 ground points. So very similar ground point counts, whether it was me taking them all the way back, initializing all the points and reclassifying, or taking the classified points. So we came up with very similar results. So kind of happy to see that. All right, both control and model key DEMs have nearly identical values. So what I did is I exported 3 different DEMs. I exported the reclassified data, I exported my control, and then I exported my model key. So I created a digital elevation model or .flt file, and I brought all 3 of those into ArcGIS. The model key and the control are identical. Now the one that I did is 3 feet higher in the Z, and I think that's because I got in there a little bit more granularly, perhaps than Fugaro did. So that may be the difference in the 3 feet and the Z. The bottom elevation is very, very nearly the same. So my conclusions are reclassified data. Um, if you're able to do it and you have a classified set, don't feel like you can't go back and redo all that work again, because you can. You will get similar results, I believe, but it may be more granular with respect to what you're actually looking for. Like I did vegetation, they didn't. I think I got tighter on some of the buildings, where I don't feel like they did. They did a good job. Probably better than I in some areas, and I think I kind of tightened up a little bit of what they did in others. So those are my conclusions. Model key points, very similar to a couple guys going out there with a total station and doing a grid and collecting a point every 50 feet or so. Obviously, it takes longer to do that than it does to fly an aircraft, um, but you're going to get similar results to that by using model key, and to generate contours. I don't see a problem with doing that. Obviously, if you want more granular data, if you want the exact um, elevation of a particular point, LiDAR data using the full set is going to be a little bit better for that. All right, well, that's my presentation. Thanks for listening. Have a good night.